In this video, I'm going to walk you through determining the probability that two people would have the same number of repeats for their STRs at a particular loci. And I'm going to walk you through the activity. We'll actually kind of go through one of the problems together. And if you ever get stuck, you can always come back and refer to this as an example. So in the activity that we were doing in class, we actually have a robbery in a jewelry store, and we got some skin cells from a forehead print that was left on the glass. And so this is our unsub's DNA. And we have 1, 2, 3, 4 different loci that we're looking at. The police also have a suspect, and the suspect's DNA is listed on, the next page. It's not in electropharogram form, it's actually in like a longhand form. So your job is to go through and see if this suspect matches the forehead print left at the crime scene. Ultimately, what we're going to do is we are going to calculate the probability of two people having 7 and 8 repeats at this particular loci, the probability of two people having 13 repeats at this loci, etc. So I'm going to show you how to do it with just this one particular example. Actually, I might throw in a little bit of information here too. So at this loci, I think that says D5S818, the unsub has 7 repeats and 8 repeats, so we would say that they are heterozygous. Well, if you notice on a future page in your packet, you have a big chart like this. This is actually real data that we have collected in the United States of a wide variety of citizens, and we've taken their blood sample, we have the different loci, and we actually have probability of those repeats listed here. So what you're going to do is you're going to find the loci that you're looking for across the top, which that first one that we were discussing is right here. And then you're going to match that with the number of repeats here on the left. So if you remember, this person had 7 and 8 repeats for this particular location. So on my chart, if I come down, here is our 7 repeats and our 8 repeats. So here's how we're going to calculate the probability using this information. So over here on your worksheet, it kind of actually spells it out for you, which I know, sorry, for some of you it might be a little confusing, but you've also maybe had this in biology class. It's kind of like a little Hardy-Weinberg. But right here, if the person is heterozygous, what we're actually going to do is we're going to take the probability of their first allele, which we're going to use the letter P for, and the probability of their second allele, and we're going to multiply that by 2. So in this case, if you remember, the person was 7, 8, that's how we would write it. The probability for that 7, if I come back to my chart, here was 0.0106. So I'm going to come back to my thing, and I do have to multiply these by 2. 0.0106, and then I need to know the probability of 8 repeats. So again, back to my chart, the probability of 8 repeats is 0.0198. 0.0198. And so on my calculator, I've got 2 times 0.0106 times 0.0198. And obviously, when I multiply decimals, I am actually getting a really small number. So 0.0004, and then if you can kind of see on my calculator there, let's go ahead and round that. 419, let's round that to 42. If you don't round, it's fine, it's not that big of a deal. Let me just quickly show you actually the next one. So this is the next loci, and I wanted to show you this because if we go back to our suspect electropharogram, we notice they're actually homozygous for this one, and calculating the homozygous is a little bit different. So there's 13 repeats for this, and we're looking for CSF1P0. So there it is, CSF1P0, and we said 13 repeats. So if I come down, it's 0.0718. So on your probability worksheet, you'll notice that for the homozygous, we do not multiply by 2. We're just simply going to square the number or multiply it by itself. So in this case, the person was 13, 13. So I'm just going to take this number times this number from my chart. So looking back at my chart, the 13 repeats was 0.0718, and I'm just going to square that. So if I use my calculator, 0.0718 times 0.0718, I get 0.00, and again I'm going to round that, so I got 5155, I'm going to do 52. Okay, so hopefully that helps kind of get that. It says show your work here. If you wanted, you could obviously show your work on the line, but this is the answer you're looking for. And then you're going to do the same for the other loci. And then down here, this is basically saying calculate the probability of someone else having a DNA profile identical to that of the suspect. And we have 4 of these in our suspect's electropherogram. So to calculate this probability, you just simply multiply all of your answers together. So this times whatever answer you have here times whatever answer you have here. And if you think about it, you should have a lot of zeros. You should have point and then a lot of zeros and then your numbers. If you have trouble understanding that on your calculator, sometimes it comes out a little funky with like one of those values. I can kind of explain that for you and show you how that works.